In this tutorial, we're going to look at solving problems, probability problems using normal distributions. So if you have never used a standardized normal distributions table before for finding probabilities, you might want to go back and have a look at the very short video on that first. Also, there's an introductory introducing normal distributions if you haven't seen normal distribution before. Okay, so in this one we're going to look straight at a problem. This is the first problem out of the ESA Learning Workbook. So if it's from the little booklet, we're looking at page 25. If you're looking at the ESA's version in the big book, then you just need to go to the probability distributions, and we're looking at exercise H, so the beginning of the notes there. So in this example, we're looking at average annual number of hours of sunshine in Blenheim is 2,500 hours with a standard deviation of 120 hours. Now, if you've had a look at our table, our standardized table, we couldn't possibly have a table for every different value of mean and then every single standard deviation that matches up with every single mean. So therefore we have to standardize these things and use our formula to standardize it so we can have one table, and in that table the mean will equal 0 and the standard deviation will equal 1. So the standard deviation is 1, mean is 0, so we're looking at one table for every scenario. Okay, so we want to find the probability that there will be more than 2,600 sunshine hours in Blenheim in any one year. So let's look at the formula. We need to find a z-score. Remember, that's our, it's like a standard deviation, but it's been standardized from any mean and any standard deviation so that we have a z-score again, and we can use the table. So this little symbol means the mean, and this one means the standard deviation. Okay, so first thing we have to do before we try and solve any normal problem is to draw a picture. Now it says to us at the beginning that the mean is 2,500 with a standard deviation of 120. So in here we're going to put the 2,500 hours of sunshine. But we want to know the probability there'll be more than 2,600. That's 2,500, 2,600 is over here somewhere. And we want to know the probability that it's more than that. So we want to know this probability. Now, if we remember our table, our normal distribution table, which was back in here, normal distributions here, we remember this table here, whoops, and we have got z-scores down here and here. So let's go back to where we're going to solve the problem. And whoopsie, sorry, I'll try and paste that table in here so we've got it handy. So if we look at this, we've now got this picture at the top of our table. Now this picture shows us here that the probabilities that we find from this table, the z-score, the probabilities are between the mean and the z-score that we're looking at, between the mean and the number of interest to us. So looking at our diagram here, we want this probability, but the table is going to give us this value in here. So now we have to go back and remember the basics of a normal distribution, and that is that it is symmetrical about the mean. So this here is a half. This here is a half. Okay, so if we look at the yellow section, we want this black shaded in piece here. The table's going to give us this. Then we want to go a half minus this probability that we find in here. Okay, So let's go ahead and try and find this probability in the speckled piece first. So looking at our formula that we had here, I'll write it down here again. So our z-score is equal to the x, that's our number of interest, 2,600, minus the mean, which was 2,500, all over the standard deviation. Now the standard deviation was 120. 120. So that gives us a z-score. I'll just look at the example in the book so I don't have to do that whole calculation. That gives us a z-score of 0.833. Now we want 1, 2, 3 decimal places. So there's our z-score. It's a positive z-score. That's what we were expecting because it's on this side of the mean. So our z-score for right at that point is equal to 0.833. So luckily that's on this little piece of table that we can see right in front of us. So the probability to match is equal to, remembering it's this probability in here that we're finding, we're going to look up 0.8 then we want 0.83, 0.2967, and there's another 3 on the end. So we want to add 8 onto the end of it. So we've got a probability equals 0.29, 67 plus 8 gives us 75. So there's our probability, but we haven't answered the question yet because the question says greater than 2,600. It's this shaded area. So our probability of 0.2973 goes in there. Remembering the yellow section is a half, we want to take this away. So a half, take away 0.2973 gives us this probability of this shaded area. So the probability that, I'll choose a different colour, probability that the x is greater than 2,600 is equal to 0.5 minus that piece in there that we made speckled, 0.2973, giving us a final answer. Shouldn't be crashing into that. This is equal to 0.2027. Okay, so we have to draw a picture first because the picture tells us if we want to go a half minus what we find, or maybe the question said less than 2,600. Now if the question had said that, we'd be looking for less than that. We'd be looking for this green area. And if we were looking for that green area, we would be going a half plus the 0.2973. Okay, so the pictures are always important. Sketch your picture first, shade what you want, use your formula to find a z-score. When you've got your z-score to 3 decimal places, go to the table, find the probability that you're after. Go back to your drawing. Is the answer exactly what I wanted? Do I need to subtract it from 0.5? Do I need to add it to 0.5? Okay, you need to do some practice on those and come up with any questions you have, take them to your teacher, and that's the end of that tutorial.